I'm just going to quickly go through the questions other classes had, and there were some of them were interesting, so maybe it's some benefit for you to hear it too. Oh. There we go. Hello. Okay. So questions about interfaces popped up. And the way that the project is setting up for interfaces, I gave an example over there saying that the name that we have, assume that the name that we have is supposed to be something that is read and writable. If that's the case, the proper design for it is to have an interface called IOable, something that makes the classes who are inheriting from it readable and writable. And we're going to have pure virtual functions for read and write, not regular functions, and overload the pure virtual functions for extraction and insertion with C in and C out. So, and instead of implementing those things starting with name, we're going to say name is an IOable object that can be inputted or outputted. Therefore, it is implementing the pure virtual functions read and write. For the virtual function read over here, we made minor modifications to make it more versatile, which was adding a delimiter, which means how far we want to read. And delimiter by default is new line, but we can change it to anything we want based on design. So any object that can be writable, it writes itself on a device. But when you are inputting it, you can tell where to stop and how far to go when you are reading it. So this is the IOable thing that we have done in here. Then we created the name, implemented read and write. So for write, what we have done was simply displaying the name. The difference is that this name that we have has now a safe state. We are not setting it to no name or anything. If the name is defaulted, we are setting the value to null. We are accomplishing that by setting the attribute of the name to null by default in the class itself, and then creating a standard default constructor, which means when they do not provide any arguments, the class will have the initial value set in its definition. Then furthermore, what we have done was this. Because of this fact, let me take this out. This was just an example. We don't need it. Somebody asked the question. Did I talk about the allocation and copying in utilities here in this class? Okay. So because the action of allocating and copying was something that was repeated over and over and over, the question came up that shouldn't that be in a function for reusability, which is absolutely right. So in utilities, we created a function called strAllocopy, which essentially is allocating and copying a string value into a pointer, and strAllocopy, which is reallocating, which means first it deletes, then allocates. That's the only difference. With strAllocopy, we passed a reference of a pointer of character to the function, which means the argument that this function is receiving becomes a new name for a pointer outside of its scope. Therefore, it can allocate memory into it. And looking at the code, this is what it looks like. Where is it? There you go. So strAllocopy receives the reference of a pointer, which means destination becomes the name of a pointer outside, sets that pointer to null first, then checks to see if the source that is coming in is null or not. If the source is not null, it will allocate memory to the size of the string and copy the value to it. Therefore, the two action of allocating and copying is within the array, is within the function. Reallocation, however, calls the string allocate copy. The only difference is that it deletes it. So if I have already existing information in my destination, I call reallocate to make sure that everything is deleted before I do anything. It makes the job much easier in programming, so I don't have to every time think about it. And these are for allocation and reallocation. Therefore, when constructor is called by value, this is redundant. I'm not because I'm checking it in str allo copy, but I'm adding it anyway over here. So it checks to make sure, first of all, the memory is there. We have something. And if we have something, there is actually data in there. It's not an empty string. If that's the case, it's going to allocate and copy it. Otherwise, object remains null. And the exact same thing happens with the copy constructor. Copy constructor does assignment operator, which makes sure that there is no self-assignment, and afterwards it reallocates everything, which means it deletes the data pointed by value, then allocates and copies the value into it. It makes the code much cleaner and easier to maintain. Writing the value for a name is no problem. Instead of printing just the name, because now I have a safe empty state, I'm going to check to see if the value is null. If it's not null, I print the value. If it is null, I print no name. So the outcome will be the same. But the difference is that I don't have any wasted memory for an empty object. Reading will do something else. So again, questions were asked that in the I/O part of the notes that we have, there's an optional part that talks about using the string object of C++, how we can get limitless amount of information from console using the string object. So again, we decided to create a method inside str utility that actually does that. And that is, this is what we see over here. Read. So this read, the one that you see over here, okay, is a function. Let me just zoom to it so we can actually focus on it. So this read function, as you see, it receives an iStream reference that is defaulted to cin, and receives a delimiter that is defaulted to new line. So if in any case I want the delimiter to be anything other than new line, like space or comma or tab or anything, I can still use this function. Okay? So what it does, from the iStream, it's going to start. Now we'll see how it's done. Let's actually take a look at the code for it. So read function works as follows. Very simple using string. And listen to me, there's a bonus thing coming. All those people who want to have more marks to have a better mark for the the subject. So this is my challenge. Now first, let's see what this thing is doing. I'm using the string object of C++. So I'm creating an empty string, and I'm creating a null pointer for a character pointer. Then I am using the helper function getLine. That getLine is not member of cin. It is a helper function. What it does, it receives an iStream object and reads into a regular character, and reads from that iStream object unlimited, limitless amount of characters and puts it in the string object until it hits the delimiter. That is a standard object helper function that we have in C++. So, and it actually returns the first argument. So getLine uses the iStream to read characters, put it in the string object up to the delimiter, and after it's done, it returns the str. So what am I doing in here? I'm saying if getLine, the return value of iStream is getLine is iStream. So if the iStream that it's returning is not in a failed state, maybe you are reading from a file and file doesn't exist or is corrupted or something like that. If that's the case, getLine may fail. If that's the case, the iStream that it returns, it's going to be in a failed state. If it is in a failed state, I'm not doing any allocation. I'm just going to return the null. But if it was successful, I'll call the string allocopy, which means I get the C string buffer of the string object, which holds the C string, null terminated array of characters containing the string, allocate and copy it, and put it in that return value that I want to return. And I return it. So this reads limitless amount of characters up to a delimiter. Okay? Now, if you can do this without the string object, there's bonus for you. Okay? And don't immediately think I'm going to go ask ChatGPT. You have to defend your code. Okay? After the code, you give it to me, you got to tell me why you did that and how you did that. Okay? So you do that, lots of bonus marks. Okay? Depending on how you implement it, lots of bonus marks. So if you can implement the exact same function as you see, as I wrote over here, without the use of the string object, okay? Which means it reads unknown amount of information from console or from iStream into a dynamic array and returns it out. And it's the exact size of the data. So if user is entering 9,562 characters, 9,562 will be the length of the dynamic string that you're supposed to return. Okay? You do that, that's a bonus mark for you. Okay? So that is the read. So using this read, in name what I'm doing, I'm saying delete the value of the name, then read the information from string up to the delimiter and put it in the value, and I return iStream. That reads a name from console. Then we go to derived classes with resources, which is the full name. Obviously, full name is the same way, which means it defaults the attribute to null, and it has a default constructor. And it has a constructor that receives the first name, but the last name is optional. So you can still create a full name that doesn't have a last name. Okay? And obviously, it has a copy constructor that it says I did not define. How is it possible? Full name. Oh, because I commented everything. I commented everything by mistake. There you go. That's much better. Let's go back. All right. So it has a copy constructor, copy assignment, the destructor. So it can follow the rule of 3, and also it implements the read and write of IOable, which means it is printable in cout using the IOable interface. Now, what are the good things about this? Like, what did we do in here? So when we look at the implementation of full name, this is what's going to look like. The full name simply passes the information to a constructor of the parent. There is nothing special about that. We have already done that. Then it checks if the last name is not null or it has some value. It allocates and copies the last name. So it's exactly like the name. For the copy constructor, however, it's different. Why is it different? Because for copy constructor, I'm not even invoking any constructors. For the copy constructor, I'm saying, hey, full name, when you get created, default your parent, which means have an empty name. Copy constructor starts with a blank thing. So the name will be blank, the last name will be blank. Then I'll call the assignment operator. The advantage of this one is that it's less coding. That's all. It's identical to line 16 that I have over there. So copy constructor calling the constructor of the parent and do re-str allo copy. So it's exact same thing. Actually, that should be a str, not re-str. Let me fix that. So, but because the parent that is full name in this case now has an empty state, which means it is null, operator equal over here is not doing any extra work. When I make the parent null, then I can simply say, call the operator equal to copy this one on me. When this happens, when the operator is called, it simply sets the name to fn. And because name was empty, it was null, no extra process will happen. It will set the name, and it will then set the last name, and it's fantastic. There is no problem. You could do it this way too. They're identical, absolutely no difference. You could say when you are copying a name, first copying a full name, first copy the name, then copy the last name. Both perfectly valid and identical processes with the same amount of overhead. Okay? Actually, this is a bit quicker than this one because it has less function call in it, but still, it's pretty okay. All right? So that's that. And after doing all this, we're going to come to this structure is okay. For writing the name, what I'm doing is I'm going to say write the first name. After writing first name, put a space, check to see if last name is null. If it's null, print no last name. If it's not, print the last name. And done. So it's going to print the name, space, last name. Reading becomes a little more tricky. Because when you are reading a name, the first read of the name cannot be terminated by \n. Usually when the name is entered, first name is the first token. Whatever comes next becomes last name. Okay? So for that, what I did over here was this. I said first call the read of the parent, and this is where the delimiter comes to play. First read the first name, stop at space. Then read the last name, stop at the delimiter, which by default is new line. And then go back, return it. So this now will take the full name perfectly. Now, if I actually come to the unit test, you will see that, oh, the CLOC, forget about it. Again, that was another question. And in utils, I have something I have to remove. That was another question that we don't need in here. So when the program runs, walking through the program, we will see that. Can you see this at the end of the class with your binoculars? All right. All right. So when the program starts, a full name is created with Barton Simpson. As you see in here, the first name is passed to the, first of all, obviously, name gets initialized, which is null. And then after that, the value of the name that is Bart will get allocated and copied into the value. Then, which is str allo copy, then it will go to the full name, initialize the attribute, and then after that, obviously, it allocates the last name that is there, and I have a last name. Then it's going to print it. To print, it goes to the IOables print method, insertion operator. But because the pure virtual of IOable is overwritten, the latest version will be called, which is going to be full names. Therefore, first the name is printed. First the name is, sorry, I pressed the wrong thing and everything got printed. It prints the first name and then the last name and comes out. Now, get name is called. We have a full name. Please take a look at the sequence in which it actually executes it. When I create the full name, it first jumps to return. You see that? And then comes back up to line 8. Did you notice what happened? One more time. So when the execution, one more time. So when it comes to here, as soon as it comes to here, after the name is created, it goes to the return statement, then comes back up and asks this. You know why it's doing that? If it was an old compiler, it wouldn't have done that. An old compiler would have first called the default constructor to create the name. Then it would do the cin, read it. Then when it comes to return statement, it would create a copy of the name and return that copy out. Then kill the name that is inside get name. Have that copy passed to assignment operator and yada, yada, yada. Now, because this is a very small amount of code and you did not do much process with that name, and that name is a local variable, compiler says, I'm going to make that my nameless object. I'm not going to recreate a new one for you. It makes your code more efficient. Okay? Because of this, it is impossible to walk through such a thing and have a perfect outcome, because depending on what is the compiler, the output will be completely different. If you go on an old compiler, you will see that the default constructor is called and yada, yada, yada. If you go and the destructor is called and then copy constructor, but in this one, you don't have any of those because it tries to make it efficient. To test this, pass an object to it and then go through this process. You will see that actually it gets copied and so on and so forth when it cannot make it local. So anyway, so that happens. It receives the name. So full name please. So it's going to be Homer J. Simpson. Receives the name. Returns it. Goes to here. So now what you have over here is a nameless temporary object that is actually the name you had over there. So what was name in get name, in here is a temporary nameless object. And it's waiting to get destroyed. That is first passed to assignment operator. So that goes to the assignment operator. So fn over here is actually the nameless or the name in that object. Assignment operator for the parent is called, reallocation is called, and it's returned. Okay? And now, right after this is done, the destructor of that nameless is called. That object that was returned from get name is destroyed. And then execution goes back to its normal stage, which hello Homer J. Simpson is going to get printed. Now the destructor of n will be called. And we are done. All right. So this was the summary of what we have done in the other class. I had so much questions that we started the thing halfway through the class. So some classes have questions, some classes don't. I broadcasted everywhere. Any questions? Suggestions? Yes, sir. Which function? Get name function? Okay. So get name function, I wanted to demonstrate what happens when you return something by value. So the copy constructor is called and so on and so forth. But it didn't go well because it optimizes the code. Okay? To do that, you have to pass an object to it, and then you will see it actually gets copied when it goes out. So if I actually do something like this, let's say I have actually, this might not call anything either. Actually, let's see if it optimizes it. Okay, so in here, I'm going to say let's see if it optimizes this one too. Will it? We'll see. Okay, so now when I call this, I have that function, the name class, the name over there that is empty, and then I have the part thingy. Now it goes to the name. So name over here is actually the name in main. It comes over here and says enter the full name. Okay, and as soon as I do this, okay, now it's going to return the name. It is by value, so originally, at this moment, because it's returned by value, a copy constructor should be called. Let's see if it happens. And in fact, it is. So now you see, when it's returned by value, copy constructor is called, a nameless object is created, and that nameless object is returned. So there is a nameless object. It's not the name, although the name is changed now because I overwritten it over here, but because it was returned by value, a copy constructor is called. And now that copy constructor goes to the assignment operator. So this fn is the nameless object, which is values are extracted and put in n. Now as soon as I get off, that nameless will die. And it says hello, and now two objects are going to die. One is the name, and the other one is the n. And that's what it is, essentially. So I just put that function over there to demonstrate if you return something by value, it will be copied. Don't do it unless you have to. Like if I would have written that thing, no, that's OOP244, forget it. Okay. Okay. Just be aware. The whole point is that when you apply rule of 3, then you don't need to worry about this. Although as you become more experienced programmer, you will notice that you're going to write your codes more efficiently, so least amount of copying and copy assignment will happen in your code. So your code becomes faster. Remember, every copying that is happening, a new memory allocation, a new object is created and then is killed and so on and so forth. Even if you don't have dynamic memory allocation, every single return thingy that you have will actually create an extra copy of the object. So as you get better and better, you're going to have a more efficient code to write. But rule of 3 with classes with resources guarantee that during that process, you're not going to have any leaks or crashes, unwanted crashes. And remember, rule of 3, when you go to OOP244, will change to rule of 5. You will find out later on what are the 2 extra things you need to create to make it even more efficient. Any other question? Full name picks what? Yes, so it takes Homer, puts it in name, and J. Simpson goes in last name. Yeah. Because the delimiter for the second part is new line, but the delimiter for the first one is space. Yeah. All right. Okay. If there's no question, I'm going to stop recording and prepare the quiz. Any question? You want to take a small break before doing the quiz?